Alrighty, my beautiful class. Can somebody please tell me for 20 million bonus points, what are we doing today? Fraction basics. Right there in plain letters. Well, not so plain letters. They're actually pretty nice letters.
Big bold letters.
Big bold letters.
Did you do those letters yourself?
Yes, I did.
Very good, double letters.
Thank you. So, fraction basics. If you did not know, fractions gonna creep up in later math for us, so that's why we have to go over it. But there's another reason why we got to go over it, is because this is a class that's combining GED students with high school 21 completion students with college students. And in the GED, for you GED folks, the first 5 questions, you will not be allowed to use a calculator. That's your first lesson for those of you that care about the GED. The first 5 questions, you won't be allowed to use the calculator. After the first 5 questions, the next 35 or 40 questions, I believe it is, you will be allowed to use the calculator. So what are they going to throw at you in those first 5 questions? Knowing that you aren't allowed to use a calculator. Well, they're going to throw simple stuff such as multiplying and dividing, right? So you got to make sure you know how to do that by hand. Multiplying, dividing decimals by hand. And yes, the dreaded fractions. Which is why, in this first week, we go over fractions. Because we need to know how to do it by hand. For some of you, we forgot, and it's going to be a review. For some of you, you already know, and it's going to be easy. No matter what, we have to learn and review fractions. So, today in particular, we're going to go over fraction basics. Such as what fractions even are, what they even are to begin with. Y'all are probably familiar with fractions like these. If you did not know, fractions is pretty much, it uses 2 numbers to represent part of a whole. So for instance, let's look at this one over here. How many pieces? Let's pretend that's a chocolate bar with, yeah, it's a chocolate bar with how many pieces in them?
4.
4, right? So the total is 4. But how many are shaded in red? How many were taken out?
3.
So obviously it's 3 over 4. That's what we grew up with. That's what we know. It's 3 over 4. But let's get into the specifics of the whats and the hows and the this and the that. To start off, do we even know? Let me move this out for a brief second. Do we know, in terms of the fraction, the top number, what is it called?
The denominator? Numerator.
Okay, you got it. Numerator. Numerator. I don't want to spell this wrong, so I'm going to look at my cheat sheet here. The numerator, and the bottom number is denominator. Top number numerator, bottom number denominator. From this point forward, you'll hear me say, add the numerator, subtract the denominator, da-da-da, da-da-da. That's your indicator to know that the top number is the numerator and the bottom is the denominator. Okay, so we now know a little bit about fractions, the basics of it. What about this one right here? How many pieces do you see?
6.
8.
6, my friend.
Sorry,
And yep.
I saw it as 8 because my eyes were crossed when I first looked at it.
That's fine. So tell me, how many pieces were taken out? 6, right? So yes, 6 out of the 6 were taken out. But later on, we're going to do a little thing called simplifying. Just right off the bat, what does 6 over 6, or what is a whole number out of the same whole number going to simplify down to be? I already heard it. It's going to become a 1. It simplifies down to a 1, because if you look at it, pretty much the whole thing was taken out. So any number over the same number will always simplify down to 1. So now comes the fun part. These ones here, even those, those ones, those are called something. Those are a specific type of fraction. There are 3 specific types of fractions. Do we know the 3 different types of fractions? Let me give you a hint. The first one that we just went over, which were those ones that I just circled, those are called proper fractions. Oopsies. Those are called proper fractions. Why are they called proper fractions? Well, if we take a look at it, 3 over 4 was the example we had before. Pretty much, the numerator is smaller than the denominator. Neil, what's proper fractions? It's a fraction in which the numerator is smaller than the denominator. You might want to write that down because you know what we have at the end of the week.
A test.
Yeah, I don't like the word
A
test.
quiz.
A quiz. And yeah, you're going to be given questions like that. What's a proper fraction? Well, you just have to define it, right? Or show an example of it. Wink, wink, hint, hint. So that's one type. Do we know another type? Yep. Improper fractions. Can somebody guess what an improper fraction is? Or Eleanor, how about you tell me because you said it?
The numerator is larger than the denominator.
Yes. Actually, I don't like that because that could be simplified down. 6 over 5. If you notice, the numerator is larger than the denominator. So guess what? That's an improper fraction. Easy peasy. Do we know the third one?
Mixed fractions. Or mixed numbers.
Oh, that's actually good. Mixed fractions or mixed numbers. You'll hear me say them both from time to time. They're both the same thing. What is a mixed fraction? Well, it's pretty straightforward. It's a fraction.
And a whole
Wait, it's a proper fraction with a whole number. So those are your 3 types of fractions. We're gonna now focus our sights on improper fractions and mixed fractions, mixed numbers. We're going to go over how they look and what they are used for. So here's this visual fraction. This, my friends, is an improper fraction / mixed number. The reason why I say slash is because, believe it or not, these two are the same thing. They're just shown in different ways. And both of them are going to come in handy for this week. So here's where we're going to see an example of how they both are the same. Here I have a diagram. Tell me, my friends. I didn't even ask the question yet. Tell me, my friends, how many, what do we want to call it? Pizzas? Pizzas, do we want to go with pizzas?
Pies.
So, okay, pies are better. They're smaller.
Cherry pie.
So how many pies do we see?
2.
Okay, not bad. So there's 3 overall pies, right? But tell me how many whole pies are taken out or eaten or whatever the case?
Two.
If you notice, there's two. There's one whole one there and one whole one there. So you put the 2 on the side. That's your whole number. That's your 2. Tell me, on the remaining pie, how many pieces are taken from the amount of pieces there are?
One.
One piece, one slice taken out of how many slices are there?
Two.
2 in this one pie. Sorry, my thing glitched out. So, guess what? Out of that diagram, out of that visual picture there, you just found the mixed number of it, pretty much. So if you're asked to find the mixed number from the following diagram, you do that. You count all the whole pieces that are taken out, in this case 1, 2, and you put it as a whole, and then whatever it is that's left over, you count as if you were just looking at it as any old normal fraction, 1 out of 2.
So, for example, the last one is divided to 4. Let's say like that. The 4 pieces.
So if we just found the mixed number of this fraction, because they told us to find the mixed fraction. What if they told us write it in improper form? Write the following fraction in improper fraction.
2.5.
That's a decimal. But I want a improper fraction. A numerator that's greater up top with the denominator below. Let me show you the trick first. How about that? The trick is this.
5, 2, 5.
So, how many pieces are in each pie?
6.
How many pieces in one pie?
Oh, 2.
2, right? So if you look at each of them, if you notice, all of them has 2 pieces. That's important because guess what? That 2 is going to be your denominator. All right? Now all you got to do is ask yourself, how many pieces overall are shaded red?
5.
So that 5 goes up top. Boom, you just found your improper fraction. And yes, improper fraction can be converted into 2 1/2 and vice versa. This is visually how you write out an improper fraction, and this is visually how you write out a mixed number. But,
Why is the 5 in there?
my bad. 2. My apologies. That will happen a lot. Please check me. Thank you for that. 20 billion bonus points for you. So, yeah, it's 2 over 1/2. So, my apologies. So, that's going to be how you find a mixed number or an improper fraction visually. But now we're going to be learning how to convert when you're given an improper fraction to a mixed number, and we're going to learn how to convert a mixed number to an improper fraction mathematically. The last thing I ever want you guys to do is whenever you're given an improper fraction, to, draw out pies, start shading them in, and see whether you can look at it and count it and be like, oh, it's 2 1/2 as a mixed number. No, don't do that. It takes too long. There's an easy mathematical way to convert improper to mixed numbers and mixed numbers to improper fractions. Why is that useful, Neil, to even learn how to convert? It's useful because of later math. So, we're given, actually let's use that example, 5 over 2. We're going to first start off with converting an improper fraction to a mixed number. And I like this example. 5 over 2. So how do you convert an improper fraction to a mixed number mathematically? Easy, my friends. We use division. 5 fractions are no different than division. When you are given 5 over 2, that means 5 divided by 2. And if you did not know, division, the numerator always goes on the inside, and the denominator goes on the outside. Same thing if we were given this. 5 divided by 2 means 5 divided by 2. That's just a little side note for y'all. You don't have any idea how many times I give this out and I see in the students' math problems that they do this, right? Because it kind of makes sense. 5 divided by 2. So they go 5 divided by 2. It's a very small common mistake, but just check yourself that you don't do that. Right. So the 5 goes on the inside, the 2 goes on the outside, and now you divide. Ask yourself, how many times does 2 go into 5? 2 can fit into 5 2 times without it going over. It obviously reaches 4. You then subtract. 5 minus 4 is 1, right? You stop there. You can continue on to get the decimal. But in terms of converting an improper fraction to a mixed number, you just stop right there. You look for your 3 numbers, and what you end up doing is rearranging them into a mixed number, into a mixed fraction. This is what we do. The number that you get as your answer when you're dividing, that becomes your whole number. The remainder that you get will become your new numerator, and the denominator will always be easy because it will always be the same as your original denominator. So this one here will always still maintain and be your denominator. Just like that, you've converted an improper fraction to a mixed number just by using simple division. Any questions so far? Is it pretty straightforward? We'll do a couple more examples, obviously. But, yeah. Let's say we are given, I don't know, that's too simple. Let's go with 9 over 4. Division, my friends. Convert this into a mixed number. How many times does 4 fit into 9? 2 times, which goes in 8 exactly. Oh, this one's almost an exact replica. But the hardest part is rearranging your stuff, all right? This one becomes your whole number. The remainder becomes your new numerator. And then the same denominator as your original. 2 and 1/4. Yeah.
It's how many times
Oh, yeah. It's
2 fits into 9.
it's how many times 4 could fit into 9. Well, no. Sorry. The 2 is how many times 4 fits into 9, right? But when you multiply that 2 with the 4, what do you get?
8.
You get 8. It's pretty much, yeah. It's pretty much the number that the 4 lands at without going over the 9, as close as it can get to the 9. Sometimes you'll get an exact number and you have a remainder of 0. But yeah, if in case you ever wonder what goes here, always just multiply these 2 numbers. The number that it fits into and then the actual number itself, and that would be what you put in right there. So 2 1/4, that is your mixed fraction. Pretty fun, huh? Not as fun as converting a mixed fraction into an improper fraction. Those are the real fun ones. Look at this right here. So here's a mixed fraction. And the question is, convert the mixed fraction into an improper fraction. So what do? Well, this cool little trick, all right? All you have to do is start at your denominator, my friends. And what you do is multiply it with the whole number. What's 7 times 3?
21.
21, right? So now you get that 21. And what you do is you add the top number, the numerator. What's 21 plus 2? So guess what? It's 23 over 3, because like I said before, they're always going to have matching denominators. So think of it like that always. Denominator multiplied by the whole number. Whatever you get as your answer, you add the top number. And just like that, you've converted your mixed fraction back into an improper fraction. When is that going to be useful? You'll see.
Is it 23 or 21?
No. 7 times 3 is 21.
Yeah.
Plus 2?
Plus 2.
Yeah, we add the numerator. You multiply 7 times 3, and then you you multiply the denominator with a whole number, and then you add the numerator. Very quick, because I forgot to do the example. So that's how you convert any mixed number to an improper fraction. You're always going to multiply the denominator with the whole number, then add the numerator. Just keep that as a routine in your head.
Denominator, we always keep it
Yep.
the same.
Yep, always keep the denominators the same. So we've learned how to do that. We've learned how to do this, but there was this one that I forgot to cover for y'all. 4 pieces. Let's do another visual just because I didn't do more than one example for it. So, tell me, my friends, how many whole pies are taken up?
3.
Whole pies, as in the complete pie
2.
were taken, eaten up, and you no longer see them, right?
2.
It's 2. That's these ones right here. Boom, boom. So now we're left with 1 here. Now all you got to do, all you got to do is count how many pieces are taken from the whole. And if you see there, it is 3 pieces taken out of 4 pieces. 3 slices taken out of 4 slices. So in this specific case, the mixed fraction is 2 3/4. Always count how many whole slices there are, and then count the remainder. In this case, 3 out of 4. Okay, we are pretty much almost done. We have covered our 3 fractions, and we've covered how to convert an improper fraction to a mixed fraction, and vice versa. We know what each of these even mean now. You know the fundamentals of fractions. Yay! One last thing. This last thing being simplifying. For some reason, simplifying gets people all the time. Simplifying is the thing that gets students every single time. First things first, let's go over, before we simplify this down to its lowest terms, let's see what simplifying even means. Simplifying in a visual standpoint just means this. Let me remember that fraction for me, 8 over 12. I might forget, so just remind me in a brief second. But let's do this example first. As simple as it can be. Tell me, in this piece of pizza, or pie, I always like saying pizza for some reason, how many slices were there?
4.
How many were taken? 2 over 4. The thing is, if we look at this pizza over here, and or pie, it's the same exact thing, although the number is different. How many slices did this pizza have? It only had 2 slices, but how many slices were taken? 1. Guess what? It is the numbers are physically different, but they're the exact same things. So this could be simplified down to 1/2. Simplifying, that's exactly what that means. It's finding the equivalent fraction. The fraction that is somewhat the same as that one, but just, lower or bigger in some cases. So what we got to do is simplify a big number, a big fraction, I should say, down to its lowest terms. Now, through practice, you're going to be able to see certain numbers and see the patterns to it and immediately know how to simplify it down to, right? But we're not, for some of you, we're not there yet, obviously. So you got to learn the tricks to start developing the skills of simplifying. How do you even simplify to begin with? Easy, my friends, using, again, division to your advantage. What you want to do is find a number that both of these can be divided by to create a whole number. What is a whole number? Pretty much a number that doesn't have a decimal. For instance,
This one should be 2, 3.
well, watch out. Let's just pretend I'm going to do this a little different. Let's pretend you're one of those students that just wanted to divide both by 3. By the way, yes, they both have to be by the same matching numbers. That's the point of simplifying. Divide both the numerator and the denominator by the same number. If you divide both of these by 3, well, 12 divided by 3 does come out as a whole number. It comes out to 4, right? But could 8 be divided by 3 without creating a decimal?
No.
No.
No, it comes out as a decimal, which is why you can't use 3.
You have
Right.
to use 4.
So, yes, you'll jump ahead and you'll get the number, but let's just say you're one of those students that still don't see the biggest number that both of them can be divided by. I teach this little trick for beginners, just for beginners, which is use the famous 2. All right, just use the infamous 2. Everyone loves dividing by 2. And hopefully they both come out as whole numbers. If they don't, if one of them comes out as a decimal, then what do? You move up to 3. If still one of them comes out as a decimal when you divide by 3, you move up to 4 and you start doing that, right? But in this case, both of them can be divisible by 2. 8 divided by 2 is what?
4.
12 divided by 2 is?
6.
6. And just like that, you came out with a simpler fraction than your original 8 over 12. But wait, there's more. You must always ask yourself whether your simplified fraction could be simplified even more. This is why students love using the divide by 2 trick. Divide by 2 again just to make sure. 4 divided by 2 is what? 6 divided by 2 is? 3. Now we have 2 over 3. If you did not know, this is the lowest term. This is the lowest fraction that 8 over 12 can get to. But if you did not know that, and you were just one of those students that still went on to divide by 2 or by 3 or by 4, whatever, you would quickly realize you can't divide anymore. Because if you divide both by 2, again, you have to divide them both by the same number. Sure, 2 divided by 2 comes out as a whole number. It comes out as a 1. But 3 divided by 2 comes out as a decimal. 1.5. So you can't divide by 2. And let's say you still want to attempt dividing by 3. Well, guess what? Now you've really went over, because 3 is bigger than the 2. You're limited to the lowest number that you got in your fraction. 2 divided by 3 comes out as a decimal again. It's a bigger, greater than 1 actually. But
if we have a decimal, so
you can't use it. You can't divide by that number. You have to move up till you get 2 whole numbers without a decimal. Or in this specific case, you can't divide anything anymore. This just happens to be that you found it. You found the lowest term of 8 over 12. 2 over 3. That's the lowest fraction that you could get to in terms of 8 over 12. And then you're done. You've simplified 8 over 12 to the lowest terms. My friends, 4 over 6 is a simplified version of 8 over 12. You're not wrong when you say 4 over 6. But if the question, my friends, if the question asks you to simplify 8 over 12 to its lowest term, your answer better be 2 over 3. Because if you put 4 over 6, guess what? It is wrong. You didn't give the test for you GED folks, or you didn't give Neil for the rest of you folks. You didn't give the lowest terms. So it has to be marked wrong. So that's your little fair warning. On the assessment that I gave out yesterday, there was one question, I think it was fractions. Yeah, it was the fraction one. It was number 34. If you notice, you all fell for the trick, kind of, for most of you. Steven, right? On number 34, if you notice, what percent of the circle below is darkly shaded? Some of you put 1 over 2. Okay, you're not... I think I gave you credit just because I didn't want to be too mean. But if you notice, the question said, what percent? You didn't even give a percent. You gave a fraction. So the reason why I'm bringing that up is always, this is your first major lesson of the day, of the quarter actually. Always read the question. For little stuff like that, that's the last thing why you want to be given a red slash on your worksheet. Because you just happen to not read the question. If the question says, give the improper and the mixed number form of the following picture, diagram, you have to give the improper fraction and the mixed number. If it says, what is the mixed number? Then you just put in the mixed number. If it says, what is the improper fraction of the following fraction, or diagram picture? then you give the improper fraction. You guys have to be on point with your guys' question, reading skills. And that is a major, 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 major advice for those of you taking the GED. The questions are going to trip you up. They're purposely made to trick you. So the last thing you want is to read something too quickly that you missed what it said. I think that is everything, my friends. What I'm going to do now is hand out the worksheet, and then we're going to get started. But before that, any questions? Alrighty.
Simplify if it's with this one. What